Mr. Berry here with end behavior discussion. We're taking a look at our higher degree polynomials and trying to pick out as much information as possible from it. Here I have y is equal to negative 12x to the fourth power minus 2x plus 5. We see three terms there. It's a trinomial, which is fantastic, but we want to talk about degree first. Degree is the largest exponent we see in the problem connected to the variable, and in this problem, it is the number 4, which we'll go ahead and figure out. We'll go ahead and circle that, I should say. And we know, just for practice sake, that the number 4, being our largest exponent, would be a quartic polynomial. So we would have a quartic trinomial here, which is fantastic. For what we're doing with end behavior, we also need to understand, is it even or is it an odd number? So obviously the number 4 is an even number. Hopefully we understand that. Certainly important to the situation here, because what that tells us here is that our end behavior, what the graph is doing on the left side and what it's doing on the right side, if we were to draw this out or have it on Desmos, means that we should be heading in the same direction, both on the left and the right. All right, so if it's an even degreed polynomial, 2, 4, 6, 8, so on and so forth, we expect the graph on the left side and the right side of the picture to be doing the same exact thing. What that is, we'll figure out with the leading coefficient here. And the leading coefficient is the coefficient that is attached to the term that has the highest degree. So here we have the biggest degree is 4. It's a quartic polynomial, and the coefficient for that term would be negative 12. So first, I'll make note that the actual number for the leading coefficient is negative 12, but we understand that when it's coming to end behavior, we need to understand if it's negative or positive, and of course, it's a negative number. And if I have a negative leading coefficient, what that means is that my picture is going to finish up going downwards. So when we're on the right side of the graph, because we read left to right, when we're on the right side of the graph, our picture would be diving downwards. Now, to make the connection to the start point, they're traveling in the same direction. We knew that because of the even degree polynomial, in this case the number 4. So if we were finishing down and we're going in the same direction to the left and to the right, we would start with a picture going downwards. All right, what will look like, we'll apply that in problems later on, but we would have something that would be having 2 arrows at the end on the left side and the right side. The arrows would be pointing down. We know that we're traveling to negative infinity off to the right. We're traveling to negative infinity off to the left as well.